Yes. All right, guys. So we're finishing up the note sheets we started Friday. We got partway through it, especially working back through with these equations here. Now, what we called 2, 3, 2, we're with these here, and we got used to using these, finding the values of h, k, and p, plugging them in either in the equation or in these piece of information here to find what we need. Now, the ones that we started with on Friday, the only difference with 2, 3, 2 and 2, 3, 1 was that for 2, 3, 1, the vertex was the point 0, 0, which means all the values of h and k were 0. And what we stopped on was this here, writing the equation of the parabola from the information given to us. So they're going to give us the vertex, well, not the vertex would be 0, 0. But there's a good chance they'll give us vertex and directrix, vertex and focus to get the information here. And as they show on the graph, the vertex is the point 0, 0. Since we have a flat line, 1, 2, 3, 4, well, y equals 3. Bless you. Now there's two ways we could go about finding the equation or our general equation that we're going to start with. One of them is just by the graph itself, because if it opens up or down, we're talking about the equation that starts off with y equals. But also, the directrix is y equals, well, the two forms, the only one that has a directrix of y equals is our y equals 1 over 4p times x minus h squared plus k. Now, even though the vertex is the point 0, 0, we can still use this starting equation here. We can always go back to these here, because our vertex is the point h comma k, and our directrix is the equation y equals k minus p. So we still need the values of h, k, and p. And in our case here, the value of h is 0, the value of k is 0, because the vertex told us h and k. H is 0, k is 0. Which is helpful, because in our equation over here, 1 over 4 times p times x minus h, well, that'd be x minus 0, plus k, which would be plus 0. So the last thing we need to do is to find the value of p. Now looking at this here, well, the only place in the information they gave us where p is located is in the directrix, or k minus p. And what it's telling us is that k minus p, when we plug the value of k and p in, we should get 3. Well, we know the value of k, it is 0. We don't know what the value of p is yet, but we know it should equal 3. Yes. Because if we simplified this here, well, 0 minus p is just negative p. And at this point, we can multiply or divide by a negative, which will tell us p is. Questions on how we found the value of h, k, or p? Now the 1 over 4 times negative 3, we could simplify that in a calculator, which is negative 1/12. X minus 0. Well, that's just the same as just having x, yes? Now, we could put parentheses around it. We don't need it because x is the only term there. Now, we can also drop them because what is the number in front of x? Well, it's not written, but it is 1. Because even if we did have a number, we'd have to square both. And 1 squared is just 1. X squared is x squared. So if it had been 2x inside the parentheses, we'd have to square both terms, which would have gave us 4x squared. But in these cases, we won't have that. And the plus 0 doesn't add anything. But this would be the final answer. Now, if you did leave it as y equals negative 1/12 x squared with the parentheses, that is still correct. That is fine. We can have it in either form. Questions on this here? Are you ready for the next one? Well, they gave us the vertex again at the origin, so it is still 0, 0. Now, they were nice enough this time, they gave us the vertex as y equals negative 2.5. They told us what it was. Now, in a general form, the vertex is the point h comma k. Our directrix is y equals k minus p. So for us here, our value of h is 0. Our value of k is 0. But we still need to find out what the value of p is. And what we're saying is k minus p is negative 2.5. I think some of you guys might have a guess at what the value of p actually is. Positive 2.5. But we can still go through the process of saying 0 minus p, negative 2.5, we plug the values in. But that's just telling us that negative p is equal to negative 2.5. Divide both sides by negative 1, telling us p is 2.5. Because there are some shortcuts to getting there, because for one, the note sheet that y'all have there does tell us that the directrix y equals negative p. So we could have started there, but again, I'm sticking to these here for one main reason. This will work with any and all parabolas in this form. And the only thing we have to finish up with is plugging in our values. So we'll plug the value of p in as 2.5, x minus 0 squared plus 0. Now we need to do 1 over 4 times 2.5 is 1/10. And that's it. Questions on these here? Question on anything we've done so far? Well, let's look at this one here. Now, they didn't give us the graph, because this is the first one that we've looked at without a graph. And on all these here, they've normally given us 2 pieces of information, yes? Because they gave us the directrix, x equals. Well, that gives us one thing, the equation, because the only one out of these here that had x equals as a directrix was our x equals equation. So we know the general form is x equals 1 over 4p times y minus k squared plus h. And it also told us the general form of the directrix is x is equal to h minus p. Now there is a more simplified version of this in the start of this note sheet, but I like sticking with these here because again, it works when it is, the vertex is 0, 0, and this way works when it's not. I don't see a whole lot of reason for learning two different ways to do this, one when it's this setup and a different when it's not, because if there's one that works every single time no matter what we do, might as well learn how to do it that way instead of learning a different way to do it in each different case. Now, what are the values of h and k? Was it told to us? Look at the instructions. Write the equation of a parabola with vertex at 0, 0. So yeah, for these here, it is always 0, 0, but the instructions did tell us vertex is at 0, 0. They just didn't place it in the problem itself. They placed it in the instructions. So the vertex is 0, 0, which means h is 0, k is 0. But again, we still need to find the value of p. And we can find that from this here because it's telling us h minus p is -3. H is 0, which is telling us negative p is equal to -3. Divide both sides by -1, telling us p is 3. So we're saying x is equal to 1 over 4 times 3, our value of p, times y minus 0 squared plus 0. And if we simplify down, our y minus 0 would just be y. We can square it, giving us y squared. Our plus 0 doesn't need to be written, so we get x equals 1 over 12 y squared. Any questions over any of this here? Any questions over anything we've done so far? As it says in the instructions, the vertex is still the point 0, 0. Which means for our h, k, and p, h and k are both 0. Now with the focus given to us, either the x value is going to change or the y value is going to change. I'm either going to add the p value to the x or h value, or I'm going to add it to the k value or y value. And if we look at this here, did the first spot or the second spot change from the vertex to the focus? The first, so we're adding it to our x value, our h value. And if we go back to the general form, we're trying to see from vertex to focus, which one matches up to that there. Because we want the first value to change. For our x equals, it does. It goes from h to h plus p. We add that value to it. And if we look at the k value, it goes from k to k. It should stay the same. So this one here is our x equals 1 over 4p times y minus k squared plus h. And our vertex is still the point h comma k, and our focus is our h plus p comma k. Now what this is also telling us is that h plus p is -2. Finding the value of p from the focus, especially with this here, is even easier because we're saying 0 plus p is -2, or that p is -2. which means for our equation, we'll have x equals 1 over 4 times negative 2, parentheses y minus 0 squared plus 0. Now our 1 over 4 times negative 2, plug it in, we can simplify it to negative 1/8. Y minus 0 squared, same as just y squared. And we get this here. Questions on any of this here? We feel comfortable with this here? Yes? Do we need to see another one? Yes? We'll look at one more. I think this is the last one we have, yes? Might as well, let's go on and look at it. Vertex is the point 0, 0. Now again, to find the equation, we need h, k, and p. The vertex tells us the h and k are 0, 0, yes? Now since we have the focus, we have to add that value of p to one of the two spots, the x spot or the y spot, the h or the k. And that'll help us determine which equation we have. Well, h comma k. Well, the h, the x value of the vertex, doesn't match the x or h value of the focus. One 0, the other 0, so that's not changing. We're not adding p to that spot. Let's look at the second spot, our y value, that k. And the vertex at 0, does it match the focus's y value? No, so that means we're adding that value of p to that second spot, that k location. And if we look at the general form, well, h, h, they match, they're the same. And that's true for our problem here. K, k plus p, that second spot changed by a certain amount. It's either going to go up or it's going to go down, one or the other. Which tells us that this focus in the general form is h comma k plus p. It's also telling us that k plus p is 3/2. Now we can go on and plug the value of k in to this here, which is just 0 plus p. And 0 plus p is just the same as p is equal to 3/2. Questions on how we found h, k, or p? We feel good with these here. Now it also did tell us the equation. Is our y equal, so we have y equals 1 over 4 times 3/2 times x minus 0 squared plus 0. Now the only thing we have left to simplify is our 1 over 4 times 3/2 is 1/6 x squared. Now if there was a number instead of 0, we would have left the parentheses as it is. I'm not going to ask you to simplify that. Questions on any of this here? And that is it.